But what we are going to do is 2.7. Are you guys ready? Fresh set of notes, 2.7. Let's go. Now, we're not really learning anything new, but what I want to do is I want to give you some examples of more complicated problems that we will solve using these trig functions. So we are solving problems involving more than one right triangle, okay? And here's an example that you see on the screen before you, right behind me. It says calculate the length of CD to the nearest tenth of a centimeter. All right. So what we're going to have to do here is we're going to have to consider the fact that we have two right triangles, and the length of CD is this length right here from C all the way here to point D. And the problem is that looking at this, I am given 26 degrees as an angle here on the triangle BCD, but I'm not given this side, I'm not given this side, I'm not given this side. I can find this angle, but if we're trying to find the length of a side, I need at least one other side, don't I? So if I had one other side, I could solve for this one. And what we find out is if we dig a little deeper, I see the second triangle here, that I can actually solve for this side because this is the, if I could draw that correctly, this is the hypotenuse of a second triangle. So you kind of have to back up a little bit, zoom out, say, I need to solve this, but I don't have the necessary givens. I don't have the necessary information. So zoom out and think, okay, how can I find what's necessary for what I'm looking for? And you got to back up a little bit, and you got to do a multi-layer. There's multi-layers to these types of problems. So I see this triangle, and I say, you know what? I'm given an angle there, and I've got the opposite side. Oh my goodness, I could find the hypotenuse pretty easy, right? So we focus on that one triangle, and you may want to, I don't know if you want to or not, but you could redraw, just resketch really quickly the right triangle, and just simplify this a little bit. 47 degrees and 4.2. And I can find the hypotenuse because I've got opposite hypotenuse, that's so, right? So sine of 47 degrees equals the opposite, 4.2, over the hypotenuse. Now, was I telling you guys yesterday, have we discussed this, that in order to rearrange the equation with a simple proportion like this, if you have the quantity on the bottom that you want to find, it's just like cross multiply dividing. This goes up to the top. This quantity right here can come to the bottom on the other side. They can kind of switch places. Have we discussed that? Yeah. Okay. So there's a bit of a shortcut. You can always just go ahead and rewrite this like this. 4.2 over sine 47. You do need to write this step, though, to clearly communicate what you're doing. So again, don't be lazy, please. Don't take too many shortcuts. Because a lot of you just write an answer, don't give me any sort of indication of how you got that answer. For all I know, you looked at the back of the book or you just got it from a buddy. So show your work, okay? This also cements in your brain a process that you will follow every time. And so that's why, even for me, like I could do a lot of this stuff in my head, but honestly, after how many years of doing this step by step to show students and to teach this, I will often show all my work so that I just don't miss any little things, and that's the way that I do it, and I get most of the answers correct. I make some mistakes like everybody else, but showing the work it allows your brain to process what you're doing, to catch any little mistakes, and you don't have to, you don't make mistakes in mental math as much if you just show your work. So after having said all that, where am I now? Okay, I'm going to do 4.2. 4.2 divided by sine 47. You don't have to close the bracket if your calculator's like mine. You don't have to close the bracket because there's nothing else after that. So if I get 5.7. Now, you want to make sure you're in degrees and not radians because these are degrees we're dealing with. So make sure your calculator is in degrees. You have a little D on your screen or a DEG, right? Not an RAD. That's another common one. We're not dealing with radians yet. So 5.74, a tenth of a centimeter. Now, here's the thing, guys. Listen, some of you are rounding. Now, the question asks for the length of CD to the nearest tenth of a centimeter. Some of you are rounding to a tenth of a centimeter throughout the question of a multi-step problem. Not a good idea. You save this last rounding to the very last step. So what I'm saying is that you should keep as many decimal places in your calculations while you're doing the question as possible, and only round at the very end. Because if you round now and you have to do like several other calculations with that rounded answer, you're going to get a very different answer at the very end. Okay, so you want to be careful. Retain or keep all the decimal places that you can throughout the question and only round at the very end. Does that make sense? You hearing me? Okay, so oftentimes you can keep this value on your calculator and just use the answer function, and it will retain all of the decimal places for you. So I'm going to write a few decimal places at least, 5.7427, whatever. 5.74277. So I'm going to show that because I'm not done the question yet, and I'm going to use that in order to solve for what I'm really trying to solve for, and that is CD. Okay? So I've got now 5.74, and now in blue I'll do the second part here for, okay, blue is I've got the hypotenuse now, and I'm looking for the adjacent. So which trig function should I use that involves the hypotenuse and the adjacent? That's AH. Which one's that? Cosine. Yeah. Very good. Use cosine. All right. We know what the cosine equation is. So I'm going to put cos 26 degrees equals adjacent side. That's my unknown. I'm going to make that CD like the question. And over the hypotenuse, which I now know is 5.74277. All right. So multiply both sides by 5.74277. And I am going to get the length of CD here is, and so I'm just going to do times, and it'll just bring down the answer there. It'll bring down my whole decimal. Times cos 26 equals, and look at this, I get 5.1615722282. That's the full answer. Now I can round to the nearest tenth of a centimeter, and I can say 5.2 centimeters. Done. Remember, we're circling one answer, we're remembering our units, we're rounding to the appropriate decimal place. Okay? All right, so here's another example. This one is also in your textbook. This is example 2 from your textbook. And it says this: from the top of a 20-meter high building, a surveyor measured the angle of elevation to the top of another building and the angle of depression. That's a new phrase for us that we'll have to memorize as well. Angle of depression, I'll explain that more in a second, of the base of that same building. Okay, so angle of elevation is the angle measured from the horizontal upwards. Horizontal up, that's the angle of elevation. The angle of depression, think about the word depression. Depress. Depress means to like push down, right? It's down. If you're depressed, you're feeling down, okay? That's the root of the word. So to depress something is to push it down. So from the horizontal, angle of depression goes down. Got it? Just like in this diagram here. So this goes downward. So this is what we've got so far. And if you see, okay, we've got two right triangles here because the horizontal line right here would form a 90-degree angle with the building. So we are assuming in all these questions that buildings are perpendicular to the ground always. So we're not talking about Leaning Tower of Pisa or anything. It's like, I don't know what that angle is. No, no. You assume it to be 90 degrees, okay? We're assuming every building is perpendicular to the surface of the ground immediately around it, okay? So the surveyor sketched his plan, or her plan, her measurements here. Determine the height of the taller building to the nearest tenth of the meter. So we want to know what is this height, the whole building. Okay? So now do you see that there's two separate right triangles here? Okay? So if I sketch those right triangles out separately over on the side, I have one like this. That has a 30-degree angle right here. And I have one here that has a 15-degree angle. Okay. And I do know that, guess what? This is 20 meters from here to here because that's the height of the building. So guess what? This height here is the same as this height right here. So I know that this section of the building is 20. Straight across from the top of the other building. See that? Awesome. So now I just need to know kind of what this top part is. And that happens to be this length of this triangle right here. With me so far? All right. Good idea to sketch. Good idea to fill your values in on your sketches. Helps you frame the question, and so you have an idea of what you're given, what you need to find, where you need to go. It ties it all together, a little bit of a sketch. Okay, so I've got enough detail here on the second triangle to find out this side right here, which would be very good because that's the same as this side on this triangle, right? So I need to solve something on this triangle first. This 20 is the opposite side to angle 15. What is this side right here? It's the, is it the hypotenuse or the adjacent? Okay, so this is the adjacent, right? So we have OA, which is TOA. So, ka, TOA. So we're looking for TOA here. All right, so let's set it up. Tan 15 degrees equals opposite is 20 over adjacent. Call that adjacent. And so I'm going to rearrange this equation. The adjacent is 20 over tan 15. We'll do that on our calculator. Do you guys know what? When I was your age in school, this is going to be really embarrassing, but the teachers did not want us to use any calculators at all. We couldn't use calculator. And a lot of us, when we were allowed to use calculators, most of us didn't have a fancy scientific calculator. It was like the basic ones that did like 2 plus 3, 5 times 2, with no sine, cos, and tan. They were like pretty fancy calculators that were really expensive, and not everybody had those. So we literally were given handouts with like trig values on them. So what we had to do is we had to go on this paper. It had like 1,000 different numbers on it, and we had to go down to, okay, 15 degrees. Where's 15 degrees? Okay, now let's go over, and what is the tangent of 15 degrees? We had to find that little number and plug that number into our calculator. We were given like a trig sheet, and it was like, I don't know, I remember that. It's a long time ago. Now we got calculators that do that, but yeah.
Did not have questions with decimals in them? Because that wouldn't have been on your sheet.
Well, no. We could figure out decimal operations, but not tan or not sine or cos, because a lot of us didn't have the scientific calculators. So they were given the trig tables. We use those decimals. So I would have to look up the tan of 15 instead, and use that decimal and multiply it by 20.
What if it was like 15.5 degrees?
Yeah, well, it didn't have every, but it had lots of the decimal degrees too, some of the tables, yeah. Funny, hey? Okay, a little aside there. So 20 divided by tan 15. Okay, 20 divided by tan 15. That's going to be 74.641. 74.641. All right, so I'm going to use that in this triangle here now. So this little triangle. Oh, come on now. Oh. Unresponsive. Ah! It's dead. It's dead. Oh, it's coming back to life. But it's not going to remember everything I did in the last little while. Okay. So, what was that number again? 74.64. 74.64. Okay. Wait a minute. So 20, yeah, I guess so. Okay, that's possible. So 20 meters high, but we got 74 meters between the buildings. They're far apart. So now in blue, let's do this. I'm going to use the adjacent side, adjacent, and the opposite. So adjacent and opposite, that is, tan again. Nice. Tan 30 degrees equals opposite side, which I do not know, over 74.64, so on, so on. So 74.64 times tan 30 equals our unknown side. Can somebody grab that door for us, please? Thanks. So this decimal times tan 30 equals 43.09. Did you guys get that? 43.09? Okay, so that's this side right here. So guess what? The rest of this top part here is 43.09 meters. And I'm going to add that to 20 to get the entire height of the building. So the height is 43.09 meters plus 20 meters is 63.09 meters. Rounded to the nearest tenth is what? 63.1 meters, correctamundo. All right, questions about that? There's the entire question. All right, your turn. Your turn, let's go. So here's the diagram. How tall is the second building? And this person is not on the top of the first building. They're just looking out the 1, 2, 3, 4, 5, 6, 7, 8, 9th floor there, looks like. And so from this person looking up at the top of the next building is a 31-degree angle of inclination, I equals. And from the same point, the base of the building is at an angle of depression of 42 degrees. And this person is exactly 39 meters above the ground. So go ahead and see if you can solve this problem exactly the same way that we solved the last one. So this is a solution, should look something like that. The answer should be approximately 65 to the nearest meter, it would be 65 meters. So the distance between the buildings looks like it's 43. Use that to find the top height of the building, which is 26. Add the 26 and the 39, and you should get the height of the next building. Okay, so can you, anybody let me know if you have a problem with that or if you need any clarification on that? All right, well, let's move on to the last and final example of the class here. Example 3, this is out of your textbook as well. You guys good? Question? Later? Later. Okay, example 3, solving a problem with triangles in different planes. Now, a plane, I'm not talking about like a plane. I'm talking about different slices of space, okay? So if you think about the horizontal plane in 3D space, that would be a slice of space that would run kind of horizontally maybe to the ground. Vertical line, vertical slice of space. So if you have something existing in one plane, think about this. The one plane is your paper, okay? So whatever, if you draw 2 lines on your paper, those 2 lines are in the same horizontal plane like this. Now, what happens if we draw a line up from the paper into space like this? That is a separate plane. So we have the plane of the paper, and then we have the plane of the vertical space here. So when we have situations in different planes, it could be like I have 3 points that are connected in the plane that's along my arm here. The tip of my arm, my shoulder, and then up above, okay? I could also have, from the tip of my shoulder, I could have another plane extending out towards you guys out there. And I could have a point here, a point there, and a point up there. So 2 different planes. Now, there are interactions between the planes, and we might have to figure that out as well. But the first thing we have to realize in a question like this, the picture here gives us a good indication of the 2 different slices of space we're talking about. So let's read the question. From the top of a 90-foot observation tower, okay, a fire ranger observes one fire due west of the tower at an angle of depression of 5 degrees. So this is going to be, in direction speaking here, this is going to be west. Okay, so from his position, that's west. That means that this is north, that the opposite way over here is east, and that this is south. Okay, does everyone see that? Okay. All right, so knowing that, we've got an angle of depression in here of 5 degrees. Okay. So I'm kind of picturing, I don't know if we're going to use this triangle or not, but I'm picturing this triangle right here. Okay. Right here. That has an angle inside here of 5 degrees. Okay. Now, also, another fire is due south of the tower. That's handy. Because why? Because this is a right angle right here. Okay. From the top of the tower, this is also a right angle, and this is also a right angle. And so we have another fire that's at a different angle of depression of 2 degrees going down. Okay? So if I were to draw this on a flat piece of paper, it would look something like this. We would have 5 degrees, and I would have, 2 degrees. Okay? Now the ground is the same distance from the top of the tower, so guess what? The 2 degree fire, if it's a little smaller angle, it has to get all the way down to ground level. So does it make sense that the 2 degree fire is further away from the tower than the 5 degree fire? A little bit? Think about it. If you are up on top of a tower and you are looking straight across you, and then you see something in the far, far distance, you look down maybe 2 degrees, you see in the far distance. Something that's closer, you will have to look down a further degree, like more degrees, right? Something that's closer. So the smaller degree represents something that's further away. All right, that's good for us to know. So how far apart are the fires to the nearest foot? Okay, so here's where the sketch, a 3D sketch, will come in very handy, because we can't view this as viewing in opposite directions. These have to be at a 90 degree angle to each other. So what I need to find is I need to find out what this distance is, and I'll do this in blue. I need to find out what this distance is right here. So that is this 90 degree angle between the directions west and south, okay? Whew, okay. So I need to try and find this distance right here, right? And I need to try and find this distance right here, if I can. Now, what other information is given? Oh, 90-foot tower. So that means that this right here is 90 feet. Okay, okay. This is a tough one. You got to really envision this one. A good sketch is going to be very helpful too. So the first triangle, okay? The first triangle. I'm gonna draw it flat though. I'm gonna draw the first triangle flat. Here's 90, okay? Here is a 90 degree angle, and here is the fire. This is W that I'm trying to find. What I'm given is an angle of depression, and this is not to scale obviously, an angle of depression of 5 degrees. So what is this angle? Because I really want to know this angle inside the triangle. So what's that angle? Anyone know? Guess?
Is because angle S, and that angle would be 90 degrees. So if you have
Yeah.
angle 5,
So that's a 5. Sorry, that looks like an S, but that's 5 degrees.
so you just do 90 minus 5.
Right, 90 minus 5 is 85 degrees inside here. Thank you. Because straight horizontal down to straight beneath you is 90 degrees. Exactly. So that's 85. Everybody see that? All right, so there we go. We've got a triangle with an angle and a side. I can find a second side. Now the other triangle is going to be, I'll draw it flat again, but it's going to be like this. It's going to be a little longer. Why? Because this angle is only 2 degrees. So this is 90, this is 90, it's the same tower. What is this angle right here? Jiham, what is it? What's that angle? Anybody over there want to help? We just talked about it over here, paying attention? This is 5 degrees, so this has to be 85 because it makes 90. What is this one?
88.
Are you having trouble seeing?
Oh, I'm scanning it. Yeah.
What's this one?
Oh, this is 2. I thought this is 20.
Okay, let me help you. That's 88. All right, if that's too small for you to see, you need to move closer to the board, okay? If it's too small, I'm sorry, but you have to move closer.
No, I read
All right.
I read 20, not 2 degrees.
That's 2 degrees. Yeah. Okay. All right. See, look, it's right up here, guys. We're talking about these same. We're talking about these two. 5 degrees, 2 degrees. Okay. We've been talking about this for 5 minutes. All right. Everybody on the same page now? Because you guys are looking like some of your space now. Okay. We good? You with me?
Yeah.
Yeah. You understanding? Okay. All right. So I need this. So I need this one, and I need this one. This side. All right. So what trigonometric function am I going to have to use if I have an angle, its opposite side, and the adjacent side.
Tan. You need to use
Tangent? Agree? Agree?
Yeah.
Yes? All right. Tangent of 85 degrees equals opposite, which we'll call W, over 90. And what about this one? Will this be tangent as well? Well, we have opposite and adjacent. So yeah, tan. Tan of 88 degrees equals opposite, that's S, over 90. So W equals 90 times tan of 85. And S equals 90 times tan of 88. So this is the first sort of layer of this question, okay? So let's do that. 90 times tan of 85 is 1028.7, so over 1,000, what is that, meters? We're talking meters? Feet. So 1028.70, 1028.70. And S is going to be then 90 tan 88. Going to be, it should be longer, let's see. Oh, it is. 2577.26. Okay. Everyone with me here so far? You got this? All right, so that means we have this length of the triangle above, we have this length, and we have this length. This is itself a 90-degree triangle, right? A right triangle. And so I'm looking for hypotenuse now. So you don't have to know any other angles. You don't have to know this angle or this angle. All you need now is to use what?
Pythagoras.
Yeah, use Pythagoras. So 1028.70 squared plus 2577.26 squared equals our distance, I'll say this is capital D, the distance squared. Or the square root of all of this equals the distance. Does that look about right?
Yeah.
Okay, so let's do one final calculation here. Square root of 1028.70. I'll use more decimal places than I need. 7 squared plus my previous answer squared. 2774. Let's see. 2774.9805. Wonderful. 2774.9805. Or the distance is, because it asked for the nearest what? Foot? So 2775 feet. All right, there's a lot to that question. There's a lot to that question. I believe in you guys. The different planes one is a bit interesting. They're a little bit tricky, okay? But if you can understand what the question's asking and draw separate triangles, some of you maybe are really good at drawing three-dimensionally, which is great. Like if you want to draw this, here's a tip, okay? Ready for the tip? When you draw the right little angle sign there, make sure that your lines are parallel with the lines above or beside them. Okay? So that looks like it's coming out at you a little bit. This one here, these are the two triangles drawn sort of in a three-dimensional sort of way. Okay? And here's the fire and the fire. And then again, so to draw the square, draw it parallel with this side, and then this one parallel with this side. So this is the 1028, right? And this is the 2577, and this is our 2774, 75. Okay? And this is my tower. Yeah, tower. And this is me up here. Okay? All right, any questions? I haven't lulled you to sleep, have I?
No, not yet.
Not yet, okay. If I keep going just a little longer though, You'll be snoring? Is this a promise? All right, here's your assignment that you've all been waiting for. Yes, I know you're excited, you're excited.
I need 20.
So this is 2.7 and the review to note, and if you want to look on, actually that's not Google, that's old. It's not Google Classroom. On my website, mrmathwell.com, you'll see all your homework assignments there.